this video we're going to go over how to solve a system of nonlinear equations using the Newton-Raphson method. So this is the iterative formula you would use using the Newton-Raphson method for this set of equations. So it involves the next set of values as a function of the initial. It involves the Jacobian matrix and the function of the initial set. So we'll do an example. So we have x squared y equals 2 and e to the xy equals 3. So first what we're going to do is write down our functions. So we have f1, which is x squared y minus 2, and we have f2, which is exy minus 3. So now what we're going to do is find the partial derivatives of both of them with respect to x and y. So df1 with respect to x, df1 with respect to y, df2 with respect to x, and df2 with respect to y. I have another video on partial derivatives in case you're not familiar. So partial derivative with respect to x is 2xy. With respect to y is just x squared. Second one, partial derivative with respect to x is yexy, and partial derivative with respect to y is xexy. And of course the constants disappear. So now that we've done that, we can construct our Jacobian matrix, which is given in the form up here. So J. So we have function 1, x and y. So 2xy and x squared. Function 2, x and y. So you might have been able to tell here that that minus 1 isn't to the power, it means inverse for matrices. So we're going to be finding the inverse of the Jacobian matrix that we have here. So what we're going to do is actually input our numbers because it's a little bit easier. So we have values x and y here. So 2 multiplied by these is 8. X squared is 16. So we have 1 e to the power of 4, and we have 4e to the power of 4. I've just left it as e because e is quite a long number, and I would simplify the answer if I rounded at this point. So now that we've got the Jacobian matrix, we're going to use it to find the inverse because we need the inverse in our formula. So the inverse of the Jacobian matrix is 1 over the determinant, which is 32e4 minus 16e4. I have another video on matrices and finding the determinants if you're not familiar, and that's multiplied by, so we swap these two, so 4e4 and 8, and then we negate these two. Okay. So now that we've got that, we can start to construct this. So we have x I plus 1, which is the next one. So x1 to 4dp, which we will find. We have the initial guess, if you see up here, the initial guess, which is 4,1, minus the inverse. So we have 1 over 32e4 minus 16e4, and that's multiplied by 4e4 minus 16 e minus 4 and, minus e to the power of 4 and 8. And then we also times by the function, so we input these values into f1 and f2, and that will give us that value. So when we put 4 into f1, like 4 and 1, into this function, we have 4 squared, 16, times 1 is 16, minus 2 is 14. And then for this one, we have e to the power of 4 minus 3, which I'll leave as that. So now we're going to solve this, and hopefully we should get a matrix for x1. So we have x9 plus 1 equals 4, 1 minus, we'll be following BODMAS, so I'm multiplying first. I have another video on matrix multiplication as well. So we have 14 and then we have, I'll just put another bracket, minus 16e4 plus 9. So we have multiplied this by this, and we multiplied this by this. Close that, and then we have negative 14e to the 4, and then we have a small bracket, 8e to the 4 minus 24. We're going to simplify the values in the brackets. We can just minus that, so that'll be 16 over 16e to the 4. And so we'll do 56. We'll do 56 minus 16. So we'd have 40e to the 4 plus 39. And then here we would have minus 14 plus 8 minus 6e to the 4 minus 24. So now we can multiply outside this matrix. So we have xi to the plus 1 equals 4, 1. And then we're going to multiply. We can save this value in our calculator, so we don't have to type it out again. Store in A, so 40e to the power of 4 plus 39 multiplied by A is 2.54464. Done it just so many decimal places because it asks for 4 dp in the question. So we don't want to round off too early. Then we would do the same with the bottom row. Then we get negative 0.424735. Once we've minused both of these matrices from each other, we should get a single matrix, which is x1. So we have 4 minus 2.544644, which gives us 1.455 to 4 decimal places. That'll be 4. And then for the next one, 1 minus minus, so plus 0.4024735. 4 decimal places, 1.4025. And that's it.